Hello and good morning, maybe good evening if you're doing this in the middle of the night, but morning for me. We're going to, time to review already because we're only cover those last two sections of chapter 9 quickly. So this is the 9.5, 9.6, ready to go on. Page 639, and the ones we're going to do are 5 through 15 all. So notice the all. You see the problems are going to go very quickly, and I figure we could use as much practice as possible. I'm going to do all the even ones on this, along with number 15. That way you're going to have all the answers for the even, as well as an example of each, plenty of examples of each types of problem. So we're reviewing chapter 9. Time to finish it up. We will be having a quiz on Monday. So a quiz on Monday on chapter 9. So let's go ahead and get into the review here. So starting with number 6. So for number 6 and 8, it says describe the effect of each change on both perimeter and the area. Okay? So number 6 says the diagonal of a rhombus in which diagonal 3 feet, another diagonal is 9 feet, and they're both multiplied by a third. Okay, now I could draw this and work my way through it, but the whole point of what we've learned is actually to show how we can solve these so easily. So I'm going to leave this largely blank, and I'm just going to show you how quickly the concept of scaling by dimensions can be applied. These problems are really easy. I've already spent too much time talking about it. We could be done. In other words, for perimeter, I'm just going to put a P. For perimeter, you just scale it exactly according to how the sides are scaled. So if we're multiplying both sides by a third, and they give us dimensions, but honestly, I don't care. It doesn't ask for them. I don't care. The perimeter, if they're multiplying by a third, then the perimeter is going to be multiplied by a third. That's all you need to put. The perimeter is going to, if the sides are reduced by a third, then the perimeter is going to be reduced by a third. And then the area, if the sides are being reduced by a third, the area is going to be reduced by that factor, if you remember, from 9.5 squared. So I just need to square 1/3, and that's how my area is being affected, because it's happening on both dimensions. So it kind of happens twice for area, and that's why we square it. So 1/3 times 1/3 is just 1/9. So I'm just going to put times 1/9. And that's it. Perimeter is scaled by timesing by 1/3, and the area is scaled by timesing by 1/9. And so 5, 6, 7, 8, and 9 you don't have to draw them. You don't have to work your way through them. You just apply that principle that I just described there. They give you these dimensions, but they're only asking for the change in perimeter and area, so that's all you have to do. Number 8. It's kind of silly because it's exactly like number 6. The base and height of a right triangle with base 15 inches and height 8 inches are multiplied by a third again. Well, good. I don't care about the dimensions. It's not asking for the new area. It's not asking for the new perimeter. It's just asking for how they're going to change. It's the exact same answer. If they're scaling by a third, then the perimeter is going to change by a third, and the area is going to change by that scaled change squared. So 1/3 times 1/3 is 1/9. So I've already finished the first two problems. 5, 7, and 9 aren't going to take any longer anyway. So number 10 is a little more interesting, so let's get to number 10. Number 10, a restaurant sells pancakes in two different sizes, silver dollar and regular. So we're going to get a scaling problem. And again, they give you the dimensions of the small pancake as 4 inches, and it says it requires 1/8 of a cup of batter to make. Then it says that the bigger pancake, or the regular pancake, is 2.5 times bigger than the smaller one, and so how much batter is it going to take? Alrighty, so again, they give us the dimensions of the small, so we've got a little pancake and a big pancake. My wife made some good pancakes the other day. Praise the Lord. So this one's 4 inches, and then they say this one is times 2.5, and they say this one takes 1/8 of a cup of batter, so how much batter is this one going to take? Well, so this is just, we think, well, the amount of batter that something takes up, that is its area. The area, I guess it actually is volume, but we're just thinking of the space. So the area of the pancake the dimensions, the diameter is increasing 2.5 times. So that's like a problem here. It's being scaled by 2.5 times. So what's it going to do to the area? Well, so let's just apply that. Area, when you scale the dimensions by a certain amount, a third, then you square that, and that tells you how much the area is changing. So we need to take this 2.5 and square it. And that will give us how much the area is changing by. So 2.5 times 2.5, do it off camera. So 2.5 squared is 6.25. So by making the diameter 2.5 times bigger, you're going to make the area times 6.25. Okay? And so that would be like answering this, how much it's changing. However, they want the actual new area. It took 1/8 of a cup here. So how much is it going to take for the larger pancake? Well, let's do what I just wrote here. 1/8 times 6.25. So let's go ahead and put that into the calculator. I'll just show you. Why not? I can do it on here. 6.25 times, and I'm going to do 1/8 like a fraction. 1 divided by 8. I put in parentheses so that it for sure creates the fraction 1/8 equals 0.78. So that means it is going to require 0.78 of a cup. Let's put some units on there to make the larger pancake. Because you increase the dimensions by 2.5, that increased the area by 2.5 squared, 6.25. So we took the old area. This was not a fraction. That's kind of what could be confusing about this problem. That's just the area of the small pancake, and we multiplied the small area by this, and that gives us 0.78. Yeah, that one maybe is a little tricky, I think, because of all the fractions involved. You kind of can lose track of what your numbers are and what they mean. But all it is a scaling problem where, again, you take the dimension, the change in dimension, and you see how that affects the area. And then you calculate what that change is. So old area times the scale change gives you the new area. Okay, on to number 12. Going to be just as easy as 6 and 8, I think even easier, where you got the spinner. And number 12 is asking for the pointer landing on red or yellow. Okay, so these are always out of these spinner problems. The possible probability is 360 degrees. So we want to know what's the number of degrees for what they're selecting for. Number 12 says red or yellow. Red and yellow are 120 and 100 together. So that means we just want to add 120 plus 100, so 220. So there's 220 possible degrees out of 360. Okay, now again, I recommend just doing this, calculating it as a percent. So I just divide those. That gives me approximately 0.61, which is 61%. So you got a 61% chance. The book gives its answer as a fraction. And again, if this was on quizzes and I'm taking my test or my quiz, I would take, and my answers were in fractions, I would give them all, I'd calculate my fractions, and you'd get, once you found a fraction that equaled 0.61, that would be your answer. The other way is you just slowly reduce this fraction, and then I can see, cancel out the 0, these each divide by 2, and so I actually see that this fraction is 11 out of 18, because I divide each of these by 2. And so if I saw that option on a test and I was like, oh, I wonder if that's the right one, I would just go 11 divided by 18. Oh yeah, 0.61. And I would know this is also my answer. So that's probably the most complicated part of this problem. This, hopefully, is pretty simple for you. Okay, number 14, just like it. Okay, number 14, the pointer land on yellow or blue. So again, same type of problem, still going to be out of 360. No more complicated. Yellow and blue combined. Yellow's 100, blue's 45. So now they combine to 145 degrees. So I would do the exact same thing. 145 divided by 360. There we go. 0.40 equals 40% chance of hitting those 2 points. Okay. Again, they reduce it. And if you, let's see, I think 145 divided by 5. Yeah, you can divide both of these by 5. And so their fraction is 29 over, let's see, 360 divided by 5, 72. To me, that's kind of a meaningless number. It's going to happen 29 times out of 72. I like to see it as a percent. And I can check that, as always. 29 divided by 72 is 0.40. Okay, so 5 problems, only a few minutes of time, plus all my over-the-top explanation. So this is a pretty easy, ready to go on. You should be able to, I think you'll knock this out very quickly. But I'm going to go ahead and do 15 because it's an example of these time problems. And because, again, it didn't take us long to do the rest of it. Why not? 15, a radio station plays 12 commercials per hour. Each commercial is 1 minute long. If you turn on the radio at random time, find the probability that a commercial will be playing. Now, this is a relevant one, right? Because we just love being stuck on commercials when we're listening or watching stuff. So you have 12 commercials per hour. So that means, and if I wanted to draw it out, I don't even think there's a reason to draw it out. You can see that you have a total time. If you're turning it on during the show, what's your total time? What's your possible? Here it was 360, but in this it's time for an hour. How many minutes? That is a total of 60 minutes in an hour. So your chances, you're turning it on sometime of 60 minutes. And so how many minutes of commercials are there? Well, it says there's 12 commercials and they're a minute long. So that just means there's 12 minutes within that hour where there are commercials playing. So there's our simple fraction of all possible minutes, selected minutes. In this case, commercials. And so there's our fraction. So we can just do 12 divided by 60, 0.2. So we have a 0.2 probability, which is 20%. So a 20% chance of hitting a commercial. If I did it the fraction way, that's 1 out of 5. So 1 out of 5 minutes, you're likely to run into a commercial. So every 5 minutes of airtime, 1 minute of that is commercial. That seems like a lot of commercials. Yep. Okay, so there you go. Area, scaling, and then probability. And we are going to be ready to go to have a quiz on Monday, 9.5 through 9.6. Tomorrow I'll assign the practice test so you can start reviewing. Next week we'll have both the quiz, the second quiz, and the Chapter 9 test. Okay, I hope you're having a great time. Reach out with any help. Got plenty of time to help you, so contact me if you need it. Be happy to do what I can for you. Miss you guys.